Hi and welcome. Today we'll be doing an example of solving a differential equation using Laplace transforms and being given initial values. Okay, so for step one, you're going to take the Laplace transform of each member of the differential equation. So the Laplace transform of y double prime minus the Laplace, we can bring the 4 out and just do the Laplace transform of y prime. The reason we can bring the 4 out, instead of doing Laplace transform of 4 y prime, just bring the 4 out because it's a linear function, so we're allowed to take out the 4, or take out the constant, equals 6, the Laplace transform of e 3t, minus 3, the Laplace transform of e to the negative t. Okay, so now we have to Laplace everything. So we have derivatives. We have to take the Laplace of a derivative. And to do that, it's just the Laplace transform of y of t. We're going to say it's capital Y of s. And then the Laplace transform of y prime of t is s times capital Y of s minus s of 0 lowercase y of 0. And the Laplace transform of y double prime of t, so the second derivative of y, is just s squared, capital Y of s, minus s to the first times y of 0, y of 0, minus s to the 0, which is just 1, times y prime of 0. Alright, so where did I get this from? The Laplace of y of t, the Laplace of y prime of t, and the Laplace of y double prime of t? I got it from this. So the Laplace of y to the n, so whatever derivative, and so the first derivative, second, third, that's n, equals s to the nth times y, capital Y of s, minus s to the n minus 1, lowercase y of 0, minus s to the n minus 2, y prime of 0, minus, and it's just a pattern, it's going to be s to the n minus 3, y double prime of 0, minus dot dot dot, minus y to the n minus 1 of 0. Okay, so that's basically how it's done. So that's the pattern here. And so for example, when we did y double prime, well, n became 2 basically, so think of it as 2. So this became 2, this became 2 minus 1, which is just 1, and this became 2 minus 2, which is just 0, y prime of 0. So it ends right there. And then etc. So that's basically the pattern. Or you could just remember these 3 things and you'd be fine. So let me erase this. Oh. Okay, so now let's substitute in the Laplace. So we have to substitute in this right now, so it's right here. Okay, so the Laplace of y double prime of t is just now s squared times capital Y of s minus s, because s to the first is just s, y of 0, minus, well, s to the 0, anything to the 0 power is just 1, so y prime of 0. Now this is where we use our initial values. Y of 0 in this case is 1, so this becomes 1. And y prime of 0 is negative 1, so this is negative 1. So let's rewrite this. So this is s squared times capital Y of s minus s plus 1. Okay, so we substituted that. Now let's do this. Negative 4 times the Laplace of y prime. Well, the Laplace of y prime we said is s, capital Y of s, minus anything to the 0 is just 1, y of 0. Now, like before, y of 0 in our case is 1. So let's just substitute that in. So y of 0 is 1. Okay, so equals 6 times, well, the Laplace transform of e to the 3t. So the Laplace transform of e to some constant, let's say a times t, is just 1 minus 1 over s minus a. So this is just from a chart. If you don't have it, just remember this. So a is our constant. A in our case is 3, right? E to the 3t. So not s. A becomes 3. So this is the Laplace transform of e to the 3t is just 1 over s minus 3. Minus 3 times 1 over, okay, so the Laplace transform of e to the negative t using this formula from which you could get on a chart, or it's good to remember this. So it's s minus, well, a in our case is negative 1, so it's going to be negative 1, so 1 over s plus 1. So this will be s plus 1. Okay, so let me erase this. So we did step 1. We took the Laplace transform of each member of the differential equation. Now we need to algebraically, so now step 2. Okay, so we did step 1. Now step 2 is we need to algebraically solve for capital Y of s. So algebraically, sorry. So algebraically solve for capital Y of s. So we need to, basically this and this stays on one side, whereas the rest we're just going to shove to the other side. So this is all just algebra from here on out. So we're going to do, let's clean this up. Let's distribute that 4 in, so then negative 4 s y of s plus 4 equals, okay, and then we have a plus 1 and a plus 4, that's just going to give us plus 5. Okay, and then okay, so we can add this and subtract this to the other side. To get s squared times capital Y of s minus 4s times capital Y of s equals 6 times y of 1 over s minus 3. Could just put that over 1 for now. Okay, and now this has a y of s and this has a y of s, so we could just factor out a y of s. Okay, and then on this side we are adding and subtracting fractions. So in order to add and subtract fractions, we need to all have the same denominator. So when we do that, the right-hand side is going to look like this. Oh, that's an S right there, not an 8. Okay, so now, remember our step 2 is just to algebraically solve for y of s, well, capital Y of s. So now we just divide by s squared minus 4s. And this gets multiplied by 1 over s squared minus 4s. So now we'll get capital Y of s equals 6s plus 1 . Okay, so then we did step 2, algebraically solve for capital Y of s. Step 3, we're going to do a partial fraction decomposition. Okay, so before we do the partial fraction decomposition, let's clean this up a bit, so just make our lives much easier when we do the partial fraction decomposition. So cleaning this up, basically distributing the 6, the negative 3, multiplying s minus 4 times s plus 1 times s minus 3, we're going to get in the numerator we'll get s 6s plus Okay, and to make our lives much easier when we do the partial fraction decomposition, this s squared minus 4s, well, they both have an s, so we can factor out that s, and we'll get s minus 4. Okay, and now let's just simplify the numerator. So we're just going to get 10s plus 30 plus s to the third minus 7s squared. Okay, so now this looks really nice. We can do our partial fraction decomposition, and this is a really nice number to do a partial fraction decomposition because take note of the denominator. The denominator has distinct linear factors. So s minus 3 is linear, s plus 1 is linear, s is linear, and s minus 4 is linear. This wouldn't be linear if we multiplied this by s minus 4 because s minus 4 times s minus 4 will get us s minus 4 squared, and that's not distinct. So it's really nice that we have distinct linear factors. And because we have distinct linear factors, it's going to be very easy to do the partial fraction decomposition. We can do the cover-up method. Now, if you don't know what the cover-up method is, it's a really fast way to do a partial fraction decomposition without much errors. So let's just do our partial fraction decomposition, and I'll show you the cover-up method. So we have 10s plus so this is going to be a over s minus 3 plus b over s plus 1 plus c over s plus d over s minus 4. Okay, so because these are distinct linear factors, we can decompose it to this. Now to solve for a, b, c, d, we're going to do the cover-up method. So that is basically, so to solve for a, we're just going to write down this. But we're going to cover up what a is on the denominator of a. So we're going to basically cover up this, right? So we're going to cover up that s minus 3. So we're just going to write s plus 1, s times s minus 4. And then now we're going to say s equals 3. S equals 3 because s minus 3 equals 0. So s minus 3, you add the 3 to the other side. So then s is just 3. That's where s equals 3 comes from. So I really like the cover-up method. You could solve this however way you like, but I'm just going to do it like this. So I cover up what a is underneath, s minus 3, and then wherever I see an s, I'm going to plug in a 3. So that will be 10 times 3 plus 30 plus 3 to the third minus 7 times 3 squared over 3 plus 1 times 3, 3 minus 4, and when you solve that, you'll get negative 2. So a is negative 2. So, alright, so we solved for a. Now let's do b. So I'm going to write it out again. Okay, so the denominator of b is s plus 1, so I'm going to cover up s plus 1. So I'm just not going to write it. Now s is going to equal negative 1 because s plus 1 equals 0, and so then we just subtract 1 to the other side. So then s is negative 1. Okay? So wherever I see an s, I'm going to plug in a negative 1. So this will be 10 times negative 1 plus 30 plus negative 1 to the third minus 7 times negative 1 squared over negative 1 minus 3 times negative 1 minus 4. And when we solve that all out, we're just going to get negative 3 over 5. So b is negative 3 over 5. So we solve for b. Alright, so let's do c. So we're going to write this out. 10s plus 30 plus s to the third minus 7s squared over, well, what's the denominator of c? It's s, so now we have to cover up s. So we won't write s, so this term we're not going to write. So it would just be s minus 4. Now s now equals 0. Okay, so we'll plug in 0 for wherever we see an s. So 10 times 0 plus 30 plus 0 to the third minus 7, 0 squared over 0 minus 3, 0 plus 1, 0 minus 4. And when we solve that, we're just going to get 5 over 2. So c is 5 over 2. And last but not least, we're going to solve for d. So d is, we're going to do 10s plus 30. Write this all out again. Okay, so for d, we're going to cover up s minus 4 in the denominator. So this is going to be, okay, so remember we're just covering up s minus 4. So this is going to be s minus 3, s plus 1 times s. Well, s is now, well, s minus 4, I'll do it over here. S minus 4 equals 0. And then we'll just add 4 to both sides. So s equals 4. So s is going to equal 4 in this case. So So then we're going to plug in a 4 anywhere we see s, so it's going to be 10 times 4 Okay, and then when we solve this out, we're just going to get 11 over 10. So D is 11 over 10. Okay, so now we're going to substitute all that back in to this, because remember, we have y of s equals this, which equals this. And so yeah, remember y of s equals this fraction over here, so this fraction over here, and then we're just simplifying it and just doing a partial fraction decomposition to get this. And now we have a, b, c, d, so we're going to plug in a, b, c, d back in. So we're going to get, so a is negative 2, so we're going to put in negative 2 here. B is negative 3 over 5, so this is going to be negative 3 over 5. C is 5 over 2. D is 11 over 10. So writing this out all neatly over here, we're going to do, so basically, capital Y of S equals negative 2 times, so, where is it? Negative 2 times 1 over S minus 3. Negative 3 over 5 times 1 over S plus 1. And then its C was 5 over 2 times, was it 1 over 5? No, right? Oh yeah, 1 over 2. It was 1 over S, sorry. I can't read my own handwriting sometimes. Alright, so we have this was A, B, C, and now we have to do D. D is 11 over 10, so plus 11 over 10, and then it was 1 over S minus 4. Okay, so now we have this, and now our last step is we're just going to take the inverse Laplace of every term in this equation. Because when we take the inverse Laplace of capital Y of S, we're just going to get little y of t. And this is what we want. So doing that, so our last step, take the inverse Laplace transform of each term in this equation. Okay, so let's do that. We could bring the negative 2 out. We just because inverse Laplace transform is linear, so we're allowed to do that. Oh, inverse. Okay, so now we have this. Now to take the, so what is the inverse Laplace? Let's just do step by step. So the inverse Laplace transform of capital Y of S is just going to be lowercase y of t. So then we're going to get minus 2. So then the inverse Laplace transform of 1 over s minus 3. Well, the inverse Laplace transform, if you had a table or, something, it's something very good to know. The inverse Laplace transform of 1 over s plus a is e to the negative a times t. So using this, we know that the inverse Laplace transform of 1 over s minus 3 is e. Well, a in our case is negative 3. So we will get negative 3 times negative a is just 3t. Okay? So we'll do that right here, e to the 3t. Minus 3 over 5 times the Laplace transform of s plus 1, which is just e to the negative t. Using this, we got that. So we did that and that, plus 5 over 2. So then the inverse Laplace transform, so it's really good to know. I mean, if you had a chart, you can see that the inverse Laplace transform of 1 over s is just 1. So this will be multiplied by 1, plus 11 over 10. And the inverse Laplace transform of 1 over s minus 4, we're just going to use this to get e to the 4t. And that's our answer. Okay. So basically, to recap really quickly, so first we took the Laplace transform of each member of this differential equation. We had to know, by doing so, we had to know what the Laplace transform of derivatives are, which is this. So we need to know the Laplace transform of our first derivative and our second derivative. Then we algebraically solve for capital Y of s, so it was just a lot of algebra here. Then we got this. And then we just simplified it and did a partial fraction decomposition. Once we did our partial fraction decomposition, we got a, b, c, and d. We plugged it back in. So then now capital Y of s is equal to this. And then we took the inverse Laplace transform of each member in this equation. And we used a chart or our knowledge of inverse Laplace transforms to get this right here, our solution. So that's it. I might do one more example in another video, but I hope this helped. Good luck.